You've probably seen firsthand that word problems pose challenges for students. The Works Clearinghouse Practice Guide on assisting students struggling with mathematics recommends strategies for supporting students with this high-priority topic. In this video, we will focus on multiplicative comparison problems, a key problem type for the upper elementary grades. We'll demonstrate strategies for making these problems more accessible to students by using concrete representations and by connecting those representations to equations. In multiplicative comparison problems, we need to compare two quantities, where one quantity is a multiple or a factor of the other. Let's try a problem to see how this works. We'll start by using small numbers to get to know this problem type. Okay, here's the problem. Matteo has 5 crayons. Elena has 3 times as many crayons as Matteo. How many crayons does Elena have? Let's make sense of the problem situation. Who has more crayons, Elena or Matteo? Elena has more crayons because she has 3 times as many as Matteo. To find out how many crayons Elena has, let's use paper plates and tiles to represent the problem. First, I'll put out a yellow plate with 5 tiles on it to represent Matteo's crayons. Next, I'll use white plates for Elena's crayons. Because Elena has 3 times as many crayons as Matteo, I'll put down 3 white plates. Now, how many tiles should I put on each of Elena's plates? If Elena had 1 times as many tiles, she would have the same number of tiles as Matteo. So that would be 5 tiles on one of Elena's plates. But Elena has 3 times as many, so we're going to put 5 tiles on each of Elena's 3 plates. Now, how many tiles does Elena have in all? 5, 10, 15 tiles. Going back to the original problem, we now know that Elena has 15 crayons. Let's write what we did as an equation. 3 times 5 equals 15. And let's label the parts of this problem. In multiplicative comparison problems, such as this one, the set that we are comparing to is called the reference set. In this case, that would be Matteo's 5 crayons. We know that Elena has 3 times as many crayons as the reference set, so I'll put a label that says multiplicative relationship is 3 times as many. And I'll also label the product, which equals 15. In the crayons problem, the product was unknown. Let's try a new problem with a different kind of unknown. Here's the problem. Amir picked 6 apples. Kenji picked 30 apples. How many times as many apples did Kenji pick as Amir? Okay, we know the number of apples that each person picked, 6 and 30. We also know Kenji picked more apples than Amir, but we don't know how many times as many. That's the multiplicative relationship that we are trying to figure out. In this problem, the reference set is Amir's apples. So we'll put out a yellow plate with 6 tiles on it to represent the apples that Amir picked. Next, we know Kenji picked 30 apples. So here's a pile of 30 tiles to represent Kenji's apples. In the crayon problem, we knew we needed 3 white plates. But in this problem, we don't yet know how many white plates to use. So let's start by putting out 1 plate. We know this plate needs to match the reference set, so we'll put 6 tiles on it, which represents 1 times as many apples as Amir. We still have more tiles to distribute, so let's put out another white plate and put 6 tiles on it. Now this is 2 times as many. We'll continue putting out plates with 6 tiles on each one until we've distributed all 30 tiles. Now we can see that there are 1, 2, 3, 4, 5 times as many as the reference set, or Amir's apples. This shows that the multiplicative relationship is 5 times as many, or that Kenji picked 5 times as many apples as Amir. We can describe this as 5 times 6 equals 30. We could also express this as 30 divided by 6 equals 5. So you can see that using concrete materials like paper plates and tiles is a powerful strategy for modeling and solving multiplicative comparison problems. We encourage you to go ahead and get out some tiles and paper plates to help your students build understanding of this important type of word problem.